Hello guys, welcome back to my YouTube channel. So our topic for today is finding the area of the normal curve. Okay, but before finding the area, let me introduce what is a normal probability distribution. So when we say a normal probability distribution, it has the following properties. Okay, so the normal probability distribution is bell-shaped. Then the curve is symmetric about its mean. When we say symmetric, if it's being splitted into halves, so each of the halves must be equal. Then the mean is equal to the median and to the mode. So in order to have a normal probability distribution, the mean, the median, and the mode must be equal. Then the spread of the curve depends on the standard deviation of the distribution. So it means to say that if the standard deviation is quite big, then it means to say that the curve might be widened and the peak might be lower. However, if the standard deviation is low, we can say that the peak can be higher and the curve will be more narrow. The tails of the curve flatten out indefinitely along the horizontal axis, asymptotic to the axis, and the area under the curve is 1. So the content of the whole normal probability distribution must be 100%. So the area under the curve is based on the probability itself. Okay, so here is the z table that I can show right now. Okay, so now we're going to find the area that corresponds to the z-score using the z-test. So our z is equal to 1.41. So in order to look for the first digits 1 and 4, or shall I say 1.4, you can find at the rows portion. So here is for 1.41. So in order to look for the last digit or the third digit, go to the columns portion. So here, you need to find the area wherein that column and row overlap. So we can say that the area is 0.4207. So we can tell that the area is 0.4207. Okay, so when we say the area for z equals negative 1.07, okay, so you just disregard the negative sign using this z table. So you need to find the area based on z is equal to 1.07. So in order to look for 1.0, you can go here, 1.0. Then if you want to go to the 7, which is in the third digit, locate it here. So we need to make sure that this must overlap or meet. This must meet. So the area for 1.07 is 0.3557. Okay, so to make things clear, I'm going to draw a diagram. Okay, so you can understand on how to find the area using the z table. Okay, so the area is 0.3577. Okay, so by the way, so this is the z table which contains area from the need. So I would rather use this so I won't get confused in terms of finding the area according to the given z value. Okay, so this is the z table that I am using for the rest of the examples. So now we're going to find the area of each given region. Okay, so first we're going to look for the area wherein z is less than 1.41. So here we can say that it can be below or less than. Okay, so first, what are we going to do is we need to find the area that corresponds to 1.41. So going back, okay, so using the z table or the previous example, we can say that our z, which is equal to 1.41, corresponds to the area of 0.4207. Area is 0.4207. Okay, so now, in order to find the area, okay, so I would rather shade the region so I could understand. Okay, so I can plot it here. It's 1.41. Okay, since the inequality is less than, so what are we going to do is we're going to shade the left side of the region. So based on the properties of the normal curve or normal probability distribution, the area is 1, right? Since the mean splits them into two equal halves, so we can say that the first half is 0.5000. Okay, for this region, okay, we can tell that it is 0.4207. Okay, so what are we going to do since we consider z values that are negative? So we are like finding the region between a negative z value and the 1.41, which is a positive value. We can say that 0.5000 plus 0.4207. So adding, so we can tell that the sum is 0.9207, or we can tell that the percentage is 92.07%. Okay, so here, for the second example, which is P, where Z is greater than 1.41, we're going to do the first step by identifying the Z score and the area that corresponds to the Z score mismo. Okay, so now we're going to do the same step, which is 1.41. So since this is greater, we can say this is above or greater than. So we can shade it at the right portion. So keep in mind that if the inequality states that it is less than, you have to shade the left portion of the region, regardless of the z value you have. While if the inequality states that it is greater than, then you have to shade the right portion of the region regardless of the z value you have. Okay, so what can I see is the right portion being shaded. Okay, so since each half has an area of 0.500, however, it shows that this half is just partially shaded. Since this is partially shaded, all we can do is we can subtract 0.5000 with 0.4207. Why subtract? Because it is just like you're finding the region between both positive values. Because when we say that our z is greater than 1.41, it means to say that you are like comparing both greater values, or let's say both positive values, since all values that are greater than 1.41 are positive. Unlike in the first example, which is z, which is less than 1.41, since this is less than, we can consider negative values being part of this inequality. However, in number 2, all must be positive since the case has mentioned that z is greater than 1.41. Okay, so that's why I had decided to subtract 0.5000 with 0.4207. So subtracting, so it will be 0.0793. So in conversion of to percentage, or shall I say when it comes to converting to percentage, we can say that this is 7.93%. Okay, if we shade the entire curve, then of course the area will be 1. Okay, so more examples, please. Okay. So let's say if our P is where the Z is less than negative 1.07. Okay, so we're going to mention the Z value basically based on the Z table. Okay, so we can say that the area that corresponds to this value is 0.3577. Okay, 0.3577. Okay, so since the Z value is negative, which is negative 1.07, we can plot here. So we can draw a bar to form a region. Okay, since this is less than the negative value, or regardless of the value, okay, so we're going to shade the left side, the left portion mismo. Okay, so we're going to shade the left side. Okay, since based on the inequality, since you are comparing both negative values, since all values that are less than negative 1.07 are negative, okay, we have to subtract 0.5000 with 0.3577. Okay, so forming the difference, it will be 0.1423 or 14.23%. So it means to say 14.23% is being shifted. Okay. So for the fourth example, which is P, wherein Z is greater than negative 1.07. Okay, so now we have the area. Okay, so we're going to plot this. Okay, so now since this is greater than, we can tell that the area, the region must be shaded at the right side. So the right portion must be shaded. Okay, so since the other half has been shaded, has been completely shaded, okay, we can easily tell that the area that corresponds to z equals negative 1.07 must be added with 0.5000. Why we're going to add this? Because based on the area, based on the region, I mean, the second half has been completely shaded. Unlike in the third example, why we deducted 0.5000 by 0.3577 because the first, as you see in this curve, that the first half of the curve has been partially shaded, while the second half of the curve has not been shaded. So we're going to find the area of the region based on the shaded figure. Okay, so it will be 0.5000 plus 0.3577. Okay, so adding, it will become 0.8577 or 85.77%. Okay, so we can tell that if the z value is greater than the negative value, or we can say that, or shall I say if the z is greater than the negative z score, all we can do is we're just going to add with 0.5000 with the area that corresponds to that negative z-score. If the z is greater than that negative value. However, if the z is less than the negative value, we're just going to subtract with 0.5000 with the area that corresponds to that negative value. So going back, okay, so we can tell that if the z value is less than the positive value, we can tell that we're going to add 0.5000 with the area that corresponds to the positive z score. However, in number 2, if the z is greater than the positive z score, we can subtract 0.5000 with the area that corresponds to the z value that is positive. Okay. So now we're going to focus on the betweenness. Okay, so we're going to find an area wherein z is between negative 1.07 and 1.41. Okay, so what are we going to do is we're going to find the area that corresponds to negative 1.07 and 1.41. So to make things simple, okay, so we're going to revisit the areas that correspond to these values. So for negative 1.07, it will be 0.3577. For 1.41, it will be 0.4207. Okay, so what are we going to do is we're going to plot. Okay, so forgive me if my drawing is not perfect. If my lines are slightly crooked, and I'm so sorry. Okay, so here, okay, so since the z is between a negative z value and a positive z value, we can shade at the bottom. Okay, so what have you noticed here? So what are we going to do since the z is between the values that have opposite signs? Okay, so all we have to do is we're just going to add both areas. So it will be 4 at the last digit, then it will be 8, it will be 7, and it will be 7. So the area based on this inequality is 77.84%. Okay, so let me double check to make things sure and concise. Okay, so double check. Okay, so tada! I'm so right. So the shaded area of the region is 77.84%. So why do we need to construct the shaded region? So we can easily understand on how to find the area of the region. So the construction or shading the area is really, really important. So you will be able to understand on how to find on the given region based on the certain inequality. Okay, so however, okay, so z lies between the negative values. Okay, so we're going to plot here negative 1.41 and negative 1.07. So we're going to shade it both. Okay, so what I have noticed here, so instead of adding those two, because this portion, there is just only one portion that has been shaded. Unlike in the previous example in number 5, why did I add both areas corresponded to these respective values? It's because two portions have been shaded. Okay, so one is from the first half, then the other is from the second half. So this serves as the border for both halves. Okay, so in here, in this number 6, okay, so the first half has just been partially shaded. So what are we going to do is we're going to subtract with both areas. So we can tell that the area is 0.0630 or 6.30%. Okay, so this is the area that corresponds to this inequality. So keep in mind that if the z is between a negative and a positive value, or shall I say a negative value and a positive value, we are going to add both areas that correspond to the respective z values. However, if the z lies in both z scores that have like signs, whether plus or no, whether positive or negative, we're just going to subtract because they lie in the same portion. Okay. To make things clear, to verify that I'm right, okay, so we're going to do the same step. I'm going to revisit. So it's 0.3577 to 0.4207. Okay, so we're going to plot it here. Okay, so we're going to shade it here. Since, okay, like in example number 6, okay, the shaded region lies in one portion. Since there are two halves, this lie in the same half, which is in the second half. Okay, so as you see, okay, so what are we going to do is we're going to subtract. Okay, so it's just the same area, it's the same amount of area. Okay, so we can say that the probability according to this inequality is 0.0620 or 6.30%. Okay, so do not forget to subscribe my YouTube channel and hit the notification bell. So happy learning, stay safe, God bless, and have a great day. Okay, so for more videos, please subscribe my button in my channel and more videos very soon. Thank you and God bless. By the way, here are the references that I have used for this lecture. Okay, so you can access to this website http colon slash slash www.mathisfun.com. If you want to look for the z table, so you go to the statistics portion. Then for area of the normal curve calculator, okay, so click this link so you can be able to find the area that corresponds to the inequality based on the z-score. Okay, so go there. This will be your guide, and this is really helpful. So have a great day.